All right, so we're going to get started with 2.6 day 2. You can go ahead and pause the video and graph the opener, the function, the rational function there. Okay, so let's see how you did here. So I say I need my domain first. Are there any restrictions? There's a denominator, and denominators can't be 0. So I'm going to say x minus 3 can't be 0, so x cannot be 3. So my domain is negative infinity to 3, union 3 to infinity. So all numbers less than 3, all numbers greater than 3. All right, next I'm going to check to see if there are any holes. So remember, if there are holes in the graph, there's going to be a common factor from numerator to denominator that would cancel out or simplify to 1. So my numerator is factorable. It factors to two numbers that multiply to give me 1 and add to give me negative 2, or negative 1 and negative 1. So what you're going to get is you're going to get an x minus 1 and an x minus 1, and nothing's going to cancel out. So therefore, there are no holes. Vertical asymptotes at the denominator equal to 0 and solve. I have x equals 3. Now I'm going to check to see if there's a horizontal or oblique asymptote. Which one is there? So you compare your degrees. Let me get this out of the way here. And compare my degrees. Degree here's 2. The degree here's 1. So the degree in the numerator is bigger. So there is no horizontal asymptote, therefore there's no oblique asymptote. To find my oblique asymptote, I use polynomial long division. So I'm going to do x squared minus 2x plus 1 divided by x minus 3. Okay, so I asked myself, what do I need to multiply x by to get x squared? That's x. I'll put that up there. Distribute my x to my x minus 3, and I have x squared minus 3x. Subtract that from the previous polynomial. I don't like subtraction, so I'm going to change it to, I don't like subtraction, so I'm going to change it to adding the opposite. These cancel. I have x plus 1. All right, now I'm looking at this and saying, what do I multiply this by to get this? That's 1. Distribute your 1, that's x minus 3. And subtract off of that polynomial. Those cancel, and I get 4 here, which is just my remainder. Okay, and remember, you disregard the remainder. Okay, so where's my oblique asymptote? That's the line y equals x plus 1. All right, x-intercepts. Your x-intercepts you get by setting y equal to 0 and solve, or f of x equal to 0 and solve. Since this is a fraction, in order for a fraction to be equal to 0, the numerator has to be equal to 0. So I'm going to set the numerator, x squared minus 2x plus 1, equal to 0 and solve. I already factored that up here, all right? So I know it's x minus 1 times x minus 1. So I get x equals 1 and x equals 1, but I'm not going to write it twice. It's just one x-intercept. So my x-intercept, remember, is a point, 1, 0. Y-intercept, 0, comma. I'm going to plug in 0 for x to see what I get for y. In my numerator, I'll get 1. In my denominator, I'll get negative 3. So 0, negative 1/3. All right, my end behavior, I'm going to have to wait because I don't know. I know it's not going to be following a horizontal line. I know it's either going to be positive or negative infinity for each end, but I just don't know which one it is yet. So let's graph this. So I'm going to graph my vertical asymptote at x equals 3. I'm going to graph my my oblique asymptote, the line y equals x plus 1. So I have a y-intercept of 1 and a slope of 1. So be super careful with your long division, because if you mess up your long division, then your oblique asymptote is going to be wrong. And then when you go to graph your points, they might be on the wrong side of the asymptote, and then it's going to totally confuse you. And you're going to be like, I know I'm doing something wrong, I just don't know what. Okay. All right, so now I'm going to graph any holes in the graph. There aren't any. So I'm going to graph my x-intercept at 1, 0, my y-intercept at 0, negative 1/3 right there. All right, so now I need to graph this. So if you look to the left of the vertical asymptote, I have 2 points. So I'm able to graph this piece. It's got to follow both of my asymptotes. That's what that piece looks like. I have no points to the right of my vertical asymptote, so I'm going to make a table of values, x comma y. And I'm going to plug in 4, which is directly to the right, and see what I get. So when I plug in 4 in my numerator, I get 16 minus 8, which is 8 plus 1, which is 9. In my denominator, I get 4 minus 3, which is 1, so I get the 0.49. All right, so I know that that piece looks like that. All right, so now I can write my end behavior. The limit as x approaches negative infinity of my function, which is f of x, is, if you look at what's happening as the x values get smaller, so are your y values. So that's negative infinity. And then the limit as x approaches positive infinity of my function f of x, as you look as your x values get bigger, so are your y values. So that is positive infinity. All right, and there's the opener. So just like in 2.6 day 1, the opener's there for a reason, okay? What we're talking about next is rational inequalities. So if you look, this looks very similar, not very similar, almost exactly like this was my function right here in the first problem. Graph that, right? Okay. So we're going to say, I want to know where the function is greater than or equal to 0. So once again, if we look back here, if I want to know where it's greater than or equal to 0, it's it's equal to 0 here, and it's greater than 0 here. Okay, I went the wrong way. Sorry, let's go back. Here, oopsies, here. I went the wrong way. Okay, so and the reason I said I went the wrong way is because I want the domain of those pieces. So if you look at it, I can get my answer already, or at least I think I can. Let's see how good I do. I think the answer is going to be 1, because it's equal to 0 at 1, union. And then there's a vertical asymptote at 3, and it's all values bigger than that, so 3 to infinity. So that's what I should get as a solution, but I need to know how to get that as a solution. Okay, so what we're going to do next is we're going to look at the steps here. So here is what you're going to do. You're going to find any restrictions in the domain, because x cannot be that. Okay, so you're going to write that down right away. So in our case, x can't be 3. Then you're going to pretend the inequality is equal to 0, or get the inequality equal to 0. Just rewrite it where it's equal to 0 instead of greater than or less than or whatever. And also you can only have one fraction on one side. You are going to simplify the other side so it's only one fraction. Wow, that was confusing. Turn it into an equation and solve it. Those are your critical values, just like with polynomials. You're going to use those critical values and the restriction, like if x can't be 3 in our case, to put all those in a sign chart. Then you're going to test a number in each interval, determine whether the value is positive or negative. And then your solution set is the values that make the inequality true, or are the values, I should say, and you're going to write that in interval notation. So once again, I didn't write that down, but those are critical values. Okay, so let's go ahead and do this algebraically and see if we can get this as an answer right here. Okay. So first off, we're going to start with, are there any restrictions on your domain? And we know that x cannot be 3. So we already know x can't be 3, okay? All right, so now we're going to do what the steps said, okay? We are going to get it equal to 0 instead. So I'm going to have x squared minus 2x plus 1 over x minus 3 equals 0. Now, here's a little trick that I like to tell everyone is that you're going to have to factor this at some point, okay? You're going to have to factor this at some point. So you could factor it now. You could wait to factor it. It's all up to you. It's what you want to do, okay? So I'm going to factor it right now. So I'm going to say, okay, this factored to x minus 1 over x minus 1, times x minus 1 all over x minus 3 greater than or equal to 0. Oops, I meant equal to 0. Equal to 0. I'm changing it to an equation, right? All right, so now in order for a fraction to be equal to 0, remember just the numerator has to be equal to 0. So I have x minus 1 times x minus 1 equals 0. And then I get x equals 1 and x equals 1. So now I have a critical value at 1. So now I'm going to put 1 and 3 on my number line. All right, here's where 1 would lie, here's where 3 would lie. All right, so now I need to decide if I'm including these or not including these. So this says do not include 3. So 3 is an open point. The 1 came from my inequality greater than or equal to. So I am including 1 as a solution. Okay, so now I'm going to test values. So I'm going to say check. And I'm going to check 3 values this time because there's 3 intervals. So I need to check a value less than 1, so I'll do 0. I'm going to check a value in between 1 and 3, so I'll check 2. And a value greater than 3, so I'm going to check 4. Okay, so now where are you plugging this in? I'd plug it in right here. It's just going to be easier math, okay? So if you look, you have 3 places for each one that you have to plug it in. Okay, so I'm going to plug in 0. 0 minus 1 is negative 1, so that's negative. 0 minus 1 is negative. 0 minus 3 is negative. So you have a negative times a negative, which is a positive, divided by a negative, which is still negative. Another way of looking looking at is these 2 cancel, but you still have this one, right? Okay, next we have to plug in 2. 2 minus 1 is positive. 2 minus 1 is positive, and then 2 minus 3 is negative. So you have a positive divided by a negative, which is negative. And then plugging in 4, you have a positive here, because 4 minus 1, 4 minus 1. And then 4 minus 3 is also positive, so that's positive. So this is negative, negative, and positive, meaning that these values, the first 2 sets of values are less than 0, and then the last set of values is greater than 0. So now if you look at what you're looking for greater than or equal to. So I still need the greater than. I already got the equal to part. Now I need to write this in interval notation where it's equal to is at 1, union, and then all values greater than 3. And you can see that's exactly what we said we were going to get. So yay. Okay, so we have 3 more examples to do. They're all fairly different. So just make sure you are sticking through each one here. Okay, are there any restrictions on the domain? So that's a yes. I know x can't be negative 1 because that would make my denominator 0. So I'm going to start off by saying x cannot be negative 1. All right, so what I'm going to do now is I'm going to factor in the numerator because the numerator is not factored, and the denominator is already factored. It's x plus 1 times x plus 1, and you can leave it as x plus 1 squared. So I need 2 numbers that multiply to give me negative 6 and add to give me 1. And that would be 3 times negative 2. So I now have x plus 3 times x minus 2 over x plus 1 quantity squared is greater than or equal to 0. So now that I remember doing this, how I taught it last year, I like to keep it in inequality at first, just that it's written equivalent to the original. Then I say, okay, now I have to solve this, pretend it's an equation. So then I pretend it's an equation in my head, and I say, okay, in order for a fraction to be equal to 0, the numerator has to be equal to 0. So then I set the numerator equal to 0, and I get x equals negative 3 and x equals 2. So now I have 3 critical values, negative 3, negative 1, and 2. I'm going to put them all on a number line. Negative 3, negative 1, and 2. All right, so now I need to know if I'm including these or not including these in my solution set. So this says right here, do not include negative 1, okay? For the other 2, I'm using my inequality. It says greater than or equal to. So equal to those values, this is where it's equal to 0, so I'm going to include those. All right, so now I'm going to check some values here. I'm going to check negative 4, negative 2, 0, and 3. That's because each one of those numbers falls in each one of these intervals. Negative 4 falls in here. Negative 2 falls in here, 0 falls here, and 3 falls in here. Okay, so let's go ahead and check those. Where am I checking? Checking them right here, okay, and that. It's already factored. It's going to be my easiest math to do. All right, so I'm going to make my 4 fraction bars here. And I have to plug it in 2 places in the top, 1 on the bottom. So you know what I'm going to do is I'm going to copy and paste. I'm going to get my 4 fraction bars out of here. And I'm going to copy and paste this just to save some time. Copy, paste, copy, paste, copy, paste. Okay, so I'm going to start by plugging in -4. So -4 plus 3 is negative. -4 minus 2 is negative. -4 plus 1 is -3, but then I'm squaring it, so that's positive. So what I realize right now is I'm squaring what's in the denominator no matter what. So the denominator is always positive, so I'm just going to run through. I have positives there. All right, now I'm going to check -2. -2 plus 3 is positive. -2 minus 2 is negative. Then I'll plug in 0. 0 plus 3 is positive. 0 minus 2 is negative. And 3 plus 3 is positive. 3 minus 2 is positive. All right, so now let's see what all these are, because I waited to do that. Notice you can do it a bunch of different ways. Okay, so this gives me a positive over a positive, which is a positive. This gives me a negative over a positive, which is a negative. Negative over a positive, which is negative. Positive over positive, which is positive. So these are all greater than 0, less than 0, less than 0, greater than 0. Look at my inequality symbol. I want greater than 0, so I want these and these. So now I want to write my solution set. That's negative infinity to -3, including 3, union 2, including 2, and everything greater than that. And there's my solution set. All right, let's try another one here. So are there any restrictions on my denominator? And there are restrictions on my denominator. My denominator can't be 0. So I'm going to say x squared minus 5x cannot be 0. I can factor this. X times x minus 5 can't be 0. So x can't be 0 and x can't be 5. Okay. And now I want to write this in factored form. So x plus 1 is not factorable. I can just leave it. My denominator I'm going to write as x times x minus 5 less than or equal to 0. Okay, so I still have to solve this if it was an equation where it was equal to. So in order for a fraction to be equal to 0, the numerator has to be equal to 0. So I'm going to say x plus 1 equals 0, x equals -1. So there's my other critical value. Okay, so I'm going to put these on a number line. There we go. I don't want it to run into my other work there. Okay, so what's on my number line? -1, 0, and 5. So 0 and 5 I'm not including for sure because it says don't include, don't include. All right, now I have to decide if I'm including this or not. Look at your inequality symbol. Its value is less than or equal to. So it's equal to -1, so I want to include that. All right, now I need to check a value on each interval. So a number less than 1, I'll do -2. A number in between -1 and 0, there's only fractions and decimals, so I'm going to have to use a fraction or a decimal. I'm going to use -1/2. In between 0 and 5, I'll choose 1, and then bigger than 5, I'll choose 6. Okay, so I have 3 places to plug this in. Once in the numerator, twice in the denominator. And once again, I'm going to use my, hey now, I don't want to do that. I'm going to use my copy and paste tool. Copy, paste. So that I can save some time here. Lovely. Okay, so let's start by plugging in -2. Where am I plugging it in? I'm plugging it in right here. Could you plug it in here? Yes, but I feel like it's easier math when it's completely factored. Okay, so plug in -2. -2 plus 1 is negative. And then I have -2 in the front, and then -2 minus 5 is -7, so that's negative. That's negative divided by a positive, which is negative, so these are negative. Plug in -1/2. -1/2 plus 1 is positive, then I have -1/2, and the -1/2 minus 5 is negative. So notice like the plugging in a negative was not difficult. Or sorry, plugging in a fraction was not difficult. All right, plug in 1. 1 plus 1 is positive, and then I have 1, and then 1 minus 5 is negative, so that's negative. Plug in 6, that's 6 plus 1 is positive, 6 is positive, 6 minus 5 is positive, so that's positive. So positive, negative, positive. Okay, so now I want to see what it's asking me for. It's asking me for values less than or equal to. So this is if you stopped listening, or like if you were at this last problem I did, you're like, I got it. Most people accidentally always choose greater than because the first couple examples are. This one says less than or equal to, so I need to choose these values and these values. I need to write that as an inequality, or sorry, not as an inequality, as an interval notation. So that's negative infinity to negative 1, including 1, union 0 to 5, not including either. And there's my solution set. Okay, the last two you should be looking at and saying, that looks different. What's making this look different on example 4? There's a +2 right here, all right? What's making example 5 look different? There's a 1 right here, all right? So if you look back to the second step, it says get the inequality equal to 0, simplify the other side so it's only one fraction, okay? So if you look at example 4, it's already equal to 0, but it's not one fraction. If you look at example 5, it's not equal to 0, so I'd have to subtract 1 from both sides, but then it's not one fraction, okay? So you have to make the left side here in this case. If it was on the right side, it's fine. You need to make it one fraction. So I need to add these two things. If I have to add a fraction to another fraction, because 2 over 1 is a fraction, what do I need in order to add two fractions? I need a common denominator. So now I need my least common denominator. My least common denominator is x plus 4. So this is already x plus 4, but I need this to have a denominator of x plus 4. So I need to get a denominator of x plus 4. In order to do that, I need to multiply the numerator and denominator by x plus 4. So now my denominator is x plus 4. And now I'm going to say what's in my numerator. I have this x minus 2. And then I have plus 2 times x plus 4. And then less than 0. Okay, so now I need to clean this up. So now I have x minus 2, and then I can distribute my 2 here. So plus 2x plus 8. And then I just have to combine like terms. So that's 3x plus 6 over x plus 4 is less than 0. Okay, so notice I did this in 2 steps. You can do it in 3, you can do it in 1. Like you could have distributed it up here and then wrote your answer. I'm fine with any of those. Okay, so here's what I'm working with. So now it's like start over. All right, so now it's just like the ones that we have been doing. Are there any restrictions on your domain? X cannot be -4. All right, because my denominator cannot be 0. Then I'm going to pretend it's an equation, and I'm going to say, okay, I have to solve this. In order for a fraction to be equal to 0, the numerator has to be equal to 0, so then I'm going to do x plus 6 equals 0. Subtract 6 from both sides. 3x equals -6. Divide by 3. X equals -2. Put -2 and -4 on a number line. -4 comes first. -2 is right here. All right, I'm definitely not including -4. And now if I look back at my inequality symbol, which is right here, it's less than. It's not less than or equal to. So I don't want to know where it's equal to. And it's equal to at -2, I'm sorry. So I am not including that in my solution set. All right, now I'm going to check some values. Check here. You don't have to write the word check, but I like to. I'm going to check -5 because that's less than -4. I'm going to check -3 because that's in between -4 and -2. And then I'm going to check 0 because that's greater than -2. You could check -1, but 0 is easier for me to check for mental math personally. All right, where am I plugging into? Right here, okay? All right, so I don't know why I did that again. I only have 2 places to plug it in. That's why, the numerator and the denominator. Okay, I'm going to plug in -5. 3 times -5 is -15, plus 6 is negative. -5 plus 4 is negative, so that's positive. So these are positive. All right, now -3. So -3 times 3 is -9, plus 6 is negative. -3 plus 4 is positive, so that's negative. Plug in 0, I get positive over positive. So that's positive. So positive, negative, positive. I'm going to look to see what I want. I want less than. So I want these values are less than 0. So my solution set is all values in between -4 and -2, not including -4, not including -2. All right, we have one problem left, okay? So once again, if you look at step number 2, it says it has to be equal to 0 in order to solve it, and find its restrictions. So we're going to have to subtract 1 from both sides first. So you can technically find the restrictions right now, but I'm going to wait until it's all cleaned up. All right, so I have x minus 3 over x plus 1 minus 1 is greater than 0. So because I subtract 1 from both sides. Okay. All right. So now it's just like the last one. I need to make this one fraction, and it's 2 fractions right now. Well, now it's 2 fractions. So I need a common denominator. My common denominator is x plus 1. So I'm going to multiply the numerator and denominator by x plus 1. My new denominator is x plus 1. And then my new numerator is x minus 3. And then I have minus 1. Or I can distribute my negative 1 right now. I'm going to do that. Distribute your negative 1, that's negative 1x. Distribute your negative 1, that's minus 1. Greater than 0. So then I have x and negative x, which cancel out. And then I have negative 4 over x plus 1 is greater than 0. All right, are there any restrictions on my denominator? Yes. My denominator cannot be equal to 0, so x cannot be equal to negative 1. Now I'm going to find where my function is equal to 0. Okay, so I need to find where my function is equal to 0. So when a fraction is equal to 0, the numerator is equal to 0. So I'm going to set the numerator equal to 0 and solve for x. There is no x, so it's never going to be equal to 0. Okay. All right, I still need to put x can't be negative 1 on my number line. So x can't be negative 1. I'm not including it. Now I'm going to check a value less than negative 1. So check. I'll check negative 2. A value greater than 1, I'm going to check 0. Where am I plugging it in? Oops, I almost erased. I'm plugging in right here. So in my fraction, no matter what, I get negative 4 in the numerator, so that's negative. And then I have to plug in negative 2 in the denominator, and I get negative, and negative divided by a negative is a positive. No matter what, I get negative in the numerator because it's negative 4 in the numerator. If I plug in 0 in the denominator, I get 1. So that's positive. Negative divided by a positive is negative. So these are positive, these are negative. I look to see what I want. Greater than. So these values are greater than. So my solution set are all values less than negative 1, or negative infinity to negative 1.